In this class, we are going to study kinetics of first order reaction. First order reactions are those reactions in which the rate of reaction only depends upon the concentration of one of the reactant. It means rate of reaction is directly proportional to concentration of one of the reactant only with power 1. For example, if a reactant A changes into product, for this reaction, rate of reaction will be directly proportional to concentration of A only. Therefore, we can write down R is equal to K A with power 1. Or if two reactants are there changing into product, but the rate of reaction only depends upon the concentration of A only, then again it will be first order reaction having the power 1 on the reactant A, means rate of reaction will only depend upon the concentration of one of the reactant A. Now, to understand the kinetics of first order reaction, we can assume the first reaction, we can take the case of first reaction where A reactant changes into product. The instantaneous rate of reaction for this particular reaction can be given in terms of minus dA by dt. Therefore, for this reaction we can write down rate of reaction minus dA upon dt, that is instantaneous rate of reaction change in the concentration of reactant A is equal to Ka. Now, if we integrate this equation with respect to A, if we integrate the equation with respect to A, we will get minus log base E A is equal to Kt plus constant of integration that we can take C, constant of integration C. Now, to find out the value of this constant of integration, we can take the initial condition where initially if the concentration of A at time t is equal to 0, concentration of A was A naught. For example, on putting the value of A into this equation, we get minus log base E A naught is equal to K time t 0 plus C. So, we are getting C is equal to minus log base E A naught. We can put the value of constant in equation 1. So, putting the value of constant in equation 1, this is the equation 1, we get minus log base E A is equal to Kt plus minus log base E A naught, the value of C minus log base E A naught kept here. Therefore, we are getting log base E A upon A naught, log base E minus log base E A upon A naught is equal to Kt, or we can say that the log base E A upon A naught becomes equal to minus Kt. So, finally, we can write down log base E A upon A naught is equal to minus Kt, or the A is equal to A naught into e to the power minus kt. In log form we can give this equation, and in exponential form we can give the equation A is equal to A naught e to the power minus kt. It means the first order kinetics is an exponential process. The first order kinetics being an exponential process, the concentration of reactant decreases exponentially with time t. The concentration of reactant decreases exponentially with time t. So, if we plot the graph for concentration of reactant against time, it will decrease exponentially with time. It will decrease exponentially with time t. Concentration of reactant in first order kinetics, in first order reaction decreases exponentially with time. To find out the value of time or rate constant in first order reaction, we can take the equation log base E equal to log base E A upon A naught equal to minus kt. On converting it to log base 10, we have to multiply it by 2.303. So, it will become 2.303 log base 10 A upon A naught is equal to minus kt, or we can say 2.303 log base 10 A upon A naught is equal to minus kt, or we can see 2.303 log base 10 A naught by A, that will be equal to kt. Negative sign taken here, therefore, A will come to denominator and A naught there. Now, time t we have to find out, it becomes 1 upon k, or we can write down 2.303 upon k log base 10 A naught by A. And to find out the value of k, we can take k is equal to 2.303 upon t log base 10 A naught upon A. So, first order reaction depends only on the concentration of one of the reactant, and therefore, time and rate constant we can get by taking the initial concentration and the final concentration. This one is initial concentration of reactant, and here we have taken final concentration of reactant. The main characteristics of first order reaction are, first thing, the rate of reaction only depends upon the concentration of one of the reactant, and the unit of rate constant k, that is time inverse. Unit of rate constant k is time inverse, it means second inverse, minute inverse or hour inverse. And the first order reaction, its rate increases with the concentration of the reactant, and concentration of reactant in first order reaction decreases exponentially with time. So, main characteristics of first order reaction. Characteristics of first order reaction. First thing, that first order reaction, in first order reaction rate only depends upon the concentration of one of the reactant, and the unit of k unit of rate constant that we can get by moles per liter to the power 1 minus n per second. N here represents order of the reaction. Therefore, for first order reaction, n value will be equal to 1. 1 minus 1 comes 0 and unit of K becomes second inverse, or we can say it will be time inverse. The concentration of reactant decreases exponentially with time, that we have already seen that first order kinetics is an exponential process. Concentration of A is equal to A naught e to the power minus kT. Concentration decreases exponentially with time. Our next thing, that in first order kinetics, if we plot log A versus t, time t, then the graph comes a straight line following y is equal to mx plus c, and the slope of the graph can be given by minus k upon 2.303. On plotting log A versus 1 by t in first order kinetics, the slope can be given by minus k upon 2.303. That we can get by the equation. Already we have seen that the log base 10 A naught by A, kT comes equal to 2.303 log base 10 A naught by A, that we have already seen. Now, if we divide the whole equation by 2.303, we can write down kT is equal to 2.303 log base 10 A naught minus log base 10 A. Taking log base 10 this side, it becomes log base 10 A is equal to log base 10 A naught minus kT upon 2.303, minus kT upon 2.303, that comes equal to log base plus log base 10 A naught. So, this equation is similar to y is equal to mx plus c. Taking time t as x and log A as y, we get the slope m, that is minus k upon 2.303. The slope of the graph of log A versus 1 by t comes equal to rate constant divided by 2.303. Next thing, that the half life of first order reaction, T half, the half life for first order reaction T half, it can be given by 0.693 upon K, because the final concentration after a half life means the time required to complete half of the reaction, the time required to change the concentration, initial concentration into its half value. A naught by 2 it will become, therefore, it comes equal to T half is equal to 0.693 upon K. If we put the value of log 2, 0.3010, on putting the value of log 2 we will get 0.693 upon K. So, half life is independent of the concentration of reactant, independent of concentration of reactant. It does not depend upon the concentration of reactant, and the concentration left after n half lives, concentration left after n half-lives. It can be given as concentration left after n half-lives, that is A can be given as A naught upon 2 to the power n, where n gives number of half-lives, n gives us number of half-lives. Number of half-life we can get dividing total time by half-life, means T upon, we can do T upon T half, that is T upon T half. So, first order kinetics being an exponential process where half-life does not depend upon concentration of reactant, and the unit of rate constant is time inverse. Thank you.